Hey guys, today we'll be talking about the top Kubernetes interview questions and some of the answers to them. And in addition to that, if you haven't already checked out the Docker interview questions, go ahead and do that because it is very helpful because Kubernetes and Dockers do tend to go hand in hand. So yeah, let's get into it. First, let's get into what Kubernetes really is. So first of all, it's an open source container orchestration system for automating application deployment, scaling, and management. It is widely used in cloud native development and operations. And for this e-learning module, we will cover 10 common Kubernetes interview questions and their answers. So let's get started with the most obvious question. What is Kubernetes? Kubernetes is an open source platform for container orchestration, and it was developed by Google and now maintained by the Cloud Native Computing Foundation. And it also allows you to manage and automate the deployment, scaling, and management of containerized applications at scale. Kubernetes provides a unified API to manage multiple containers across multiple hosts and helps you define your application and its dependencies using a declarative configuration language. It can manage containers running on a single machine or a cluster of machines and can automatically scale up or down based on demand. You can kind of think of it like a traffic cop for your containers, making sure they don't crash into each other and get to where they need to go without any hiccups. It's pretty much the go-to tool for container orchestrations in the world of software development these days. In addition to automating the deployment and scaling of containerized applications, Kubernetes can also help you achieve high availability by automatically rescheduling containers if a node fails. This makes it a popular choice for environments where applications are constantly changing, updating, and Kubernetes has become extremely popular in the recent years and is used by many of the world's largest companies to manage their containerized applications. Its popularity is partially due to its flexibility and ease of use, as well as its vibrant ecosystem of tools and add-ons that have been developed around it. So, question 2. What is a pod in Kubernetes? So, in Kubernetes, a pod is the smallest and simplest unit of deployment. It represents a single instance of a running process in a cluster. Think of it as a container for your container. A pod can contain one or more containers which share the same network namespace and can communicate with each other through local hosts. This makes it easy to manage multiple containers that work together to provide a single service. When you create a pod, you define the container image to use, the amount of CPU and memory resource to allocate, and other configuration details. Kubernetes then schedules the pod to run on a specific node in the cluster based on availability and resource requirements. One thing to keep in mind is that pods are considered disposable. They can be created, deleted, or replaced at any time. To ensure high availability and scalability, Kubernetes can automatically manage the lifecycle of pods, scaling them up or down as needed. Overall, pods are the fundamental building block of Kubernetes architecture, and they provide a lightweight and flexible way to manage containerized applications in a distributed system. You could kind of think of a pod as a group of actors in a play or a movie, just like how each actor plays a different role, but works together with other actors to create a story. A pod in Kubernetes can contain one or more containers that work together to provide a service. When a play or movie is produced, the director decides which actor to cast for each role and how they should interact with each other. Similarly, when you create a pod in Kubernetes, you define which container image to use and how they should communicate with each other. Just as actors rehearse and perform on a stage or set, a pod in Kubernetes runs on a specific node in the cluster. And just like how actors can be replaced or new actors can be added to production, pods in Kubernetes are disposable and can be created, deleted, or replaced as needed. So moving on to question 3, what is a Kubernetes service? In Kubernetes, a service is an abstraction layer that provides a way to group a set of pods and access them through a single endpoint. Think of it as a load balancer that distributes incoming traffic to appropriate pods. When you create a service in Kubernetes, you define the pods that should be part of the service, along with a label selector that matches those pods. Kubernetes then assigns a stable IP address to the service, which can be used to access the pods. One of the main benefits of using a service in Kubernetes is that it provides a way to decouple the front end and back end of an application. The front end can use the IP address of the service to access the back end without needing to know the specific IP address of the pods. Another benefit of using a service is that it provides a way to scale your application horizontally. You can add or remove pods from the service, and Kubernetes will automatically update the load balancing rules to distribute traffic to the new set of pods. Overall, a service in Kubernetes is a way to group a set of pods and access them through a stable IP address. It provides load balancing and scaling and decoupling of the front end and back end of an application. Question 4. What is a Kubernetes deployment? In Kubernetes, a deployment is a higher level abstraction layer that provides a way to manage the rollout and scaling of a set of replicas of your application. Think of it as a way to ensure that your application is always available and running as expected. When you create a deployment in Kubernetes, you define the desired state of your application, including the number of replicas, the container image to use, and other configuration details. Kubernetes then schedules the deployment of those replicas across the available nodes in the cluster. One of the main benefits of using the deployment in Kubernetes is that it provides a way to perform rolling updates and rollbacks of your application. You can update the container images, configuration settings, or other details of your application. And Kubernetes will gradually update the replicas one by one, ensuring that your application remains available throughout the process. Another benefit of using a deployment is that it provides a way to scale your application up or down automatically. You can adjust the number of replicas in the deployment, and it'll automatically manage the scaling of the replicas to ensure that the desired state is always met. Overall, a deployment in Kubernetes is a way to manage the rollout, scaling of a set of replicas in your application. It provides rolling updates, rollbacks, and scaling capabilities, ensuring that your application is always available and running as expected. So for question 5, it's what is a Kubernetes replica set? In Kubernetes, a replica set is a lower-level abstraction layer that provides a way to ensure that a specified number of replicas of your application are running at all times. Think of it as a controller that monitors the state of your application and ensures that the desired number of replicas are available. When you create a replica set in Kubernetes, you define the number of replicas of your application that should be running, along with other configuration details like the container images to use, any required resources. Kubernetes then creates and schedules the specified number of replicas across the available nodes in the cluster. One of the main benefits of using a replica set in Kubernetes is that it provides a way to recover from failures automatically. If one or more replicas of your application fail, the replica set controller will automatically create new replicas to replace them, ensuring that the desired number of replicas are always available. Another benefit of using a replica set is that it provides a way to scale your application horizontally. You can add or remove replicas from a replica set, and Kubernetes will automatically manage the deployment of those replicas to ensure that the desired state is always met. Overall, a replica set in Kubernetes is a way to ensure that the specified number of replicas of your applications are running at all times. It provides automatic recovery from failures and scaling capabilities, ensuring that your application is always available and running as expected. So for question 6, we have what is a Kubernetes config map? In Kubernetes, a config map is an API object that provides a way to store configuration data as key value pairs, separate from your application code. Think of it as a way to keep your application configuration separate from your application logic, allowing you to manage and update the configuration without changing your application code. When you create a config map in Kubernetes, you define the key value pairs that represent your configuration data. These key value pairs can be used as an environment variables or mounted as files within your application containers. One of the main benefits of using a config map in Kubernetes is that it provides a way for you to configure your application without having to rebuild and redeploy the entire application. You can create a config map with the desired configuration values and then update the config map as needed without changing your application code. Another benefit of using a config map is that it provides a way to manage configuration values for multiple applications in a consistent way. You can create a single config map that contains configuration values for multiple applications, then use that config map across your clusters. Overall, a config map in Kubernetes is a way to store configuration data as key value pairs, separate from your application code. It provides a way to manage and update configuration values without changing your application code, and can be used across multiple applications in a consistent way. So, on question 7, we have what is a Kubernetes secret? In Kubernetes, a secret is an API object that provides a way to store and manage sensitive information, such as passwords, API keys, or SSL certificates, in a secure manner. Think of it as a way to keep your sensitive data separate from your application code and configuration, ensuring that it is protected from unauthorized access. When you create a secret in Kubernetes, you define the sensitive data that you want to store, such as a password or API key. This data is then encoded and stored as a key value pair in the secret object. One of the main benefits of using a secret in Kubernetes is that it provides a way to manage sensitive information separately from your application code and configuration. You can create a secret with the sensitive data and then reference the secret within your application code or configuration as needed. Another benefit of using a secret is that it provides a way to ensure that the same sensitive data is encrypted at rest and in transit. Kubernetes automatically encrypts secret data before storing it, and the Kubernetes key value store and ensures that it's only available to authorized applications. Imagine you're building a web application that needs to connect to a database. You might store the database connection information, such as the host name, port number, and credentials, in a configuration file. In Kubernetes, you could use a config map to store this configuration data as key value pairs and mount the config map as a volume in your application containers. However, because the database credentials are sensitive information, you don't want to store them in a plain text in config map. So instead, you can use a secret to store the database credentials securely. The secret data is encoded and stored in Kubernetes secret object and can be referenced within your application code or configuration as needed. In this example, the config map stores non-sensitive configuration data such as hostname and the port number, while the secret stores sensitive information such as database credentials. This ensures that the sensitive data is protected from unauthorized access, while still allowing you to manage and update the configuration data separately from your application code. So for question 8, we have what is a Kubernetes stateful set? In Kubernetes, a stateful set is an API object that provides a way to manage stateful applications, such as databases, where each instance of the application requires stable network identifiers and persistent storage. Unlike a deployment, which manages stateless applications, a stateful set manages stateful applications in a deterministic way, providing unique and persistent network identifiers, such as host names or stable DNS names, for each pod in the set. This allows for stable and predictable network communication between pods, even when the set is scaled up or down. In addition to providing the stable network identifiers, a stateful set also manages persistent storage for each pod in the set. This ensures that the data is preserved even when a pod is rescheduled or recreated, allowing for reliable and consistent data storage for stateful applications. One of the main benefits of using a stateful set in Kubernetes is that it allows you to manage stateful applications in a scalable and reliable way, while still providing stable network identifiers and persistent storage for each pod in the set. This makes it ideal for running databases, message brokers, and other stateful applications in a Kubernetes cluster. Let's say you're running a microservice-based application that requires MySQL database for data storage. To ensure reliable and consistent data storage, you decide to run MySQL as a stateful application in your Kubernetes cluster using a stateful set. You would create a stateful set manifest, defining the desired number of MySQL replicas, persistent volume claims, and network settings. The manifest would also specify a unique hostname or DNS name for each MySQL pod in the set, ensuring stable network identifiers for each pod. Once the stateful set is created, Kubernetes would automatically create the required number of MySQL pods with unique hostnames, each with its own persistent volume claim for data storage. Kubernetes would also manage the network settings and ensure that stable network communication is established between the MySQL pods. If you need to scale the number of MySQL replicas up or down, Kubernetes would automatically update the stateful set and create or delete the necessary pods, while preserving the stable network identifiers and persistent storage for each pod. Overall, by using stateful set to manage MySQL as a stateful application in your Kubernetes cluster, you can ensure reliable and consistent data storage while still allowing for scalable management of the MySQL replicas. Okay, so for question 9, we have what is a Kubernetes daemon set? In Kubernetes, a daemon set is an API object that provides a way to manage a set of pods that run on every node in a cluster. This is useful for running system-level or infrastructure-related tasks, such as log collection, monitoring, or network management that need to run on every node in the cluster. Unlike a deployment or stateful set, which manages a set of pods that can be distributed across the cluster, a daemon set ensures that a copy of a pod is running on every node in the cluster. This makes it ideal for a running task that needs to be performed by every node, such as collecting metrics or logs from all nodes in the cluster. One of the main benefits of using a daemon set in Kubernetes is that it allows you to manage system-level or infrastructure-related tasks in a scalable and consistent way, ensuring that every node in the cluster is running the same set of pods. This makes it easier to manage and troubleshoot these tasks, as you can be sure that they are being performed consistently across the cluster. A daemon set is like a task you want to make sure is performed on every computer in a group or organization. For example, suppose you want to work for a company with many branches, and you want to ensure that every computer in each branch has a particular software installed. Instead of manually installing the software on each computer, you could use a tool to automatically install the software on every computer in the branch. A daemon set in Kubernetes is similar in that it ensures that a particular set of pods or tasks are running on every node in a Kubernetes cluster, making it easier to manage and monitor the entire system. So for our last and final question, we have what is Kubernetes Ingress? So Kubernetes Ingress is an API object that manages external access to the service in a Kubernetes cluster. It provides a way to configure routing rules, SSL TLS termination, load balancing, and it can be configured using various tools and platforms such as Nginx, Traefik, and Istio. That will be the end of our 10 questions for Kubernetes. So if you have any questions, go ahead and ask in the comments, and I hope you enjoyed the video. Thank you.